This is the fifth in a series of courses so far, which I think have been fairly popular. Had a good number of attendees, and I'm probably going to ruin it today, but let's go with that anyway and see how it goes. So first thing is, I've set up a Slack channel for anyone who wants to get on it. From some feedback, this is an opportunity to just put some questions, not mainly for you guys, you can ask me here in London, but for the other delivery centres, if you get onto that Slack channel there, you can ask questions as you go along.
Conveniently looks like you're raising money for this.
Well, we don't earn much, you know, so that's fair enough. That's true, yes. Okay. Some objectives today then. This is what I think objectives are today. An understanding generally of how architecture does benefit yourselves, us as individuals. I don't think that's always very clear to people. I know some projects don't think they need architects, so let's go with how architecture could benefit a project. Let's get a definition of what architecture is, try and work that out together, and then hopefully understand how an architect fits in. That's the agenda for today. A little bit of boring stuff about me. It won't take too long there, and we'll see how boring it is. Have a bit of a discussion on what is architecture. So guys on the delivery centre, get ready to put your comments there, and obviously you guys join in. Talk a bit about some architectural styles. Not going to delve too deeply into them. We're going to have other courses, other talks, where we'll get into a little bit more detail on what those architectural styles are. This is an opportunity just to get some high level of some of them. Probably the bulk of this will be principles of architecture. For me, this is what's going to help people decide what is and isn't a good architecture. Good architecture is always an opinion, but the principles are what will help lead us to what is and isn't a good opinion. If we've got time, we'll do a case. Even if we don't have time, what I'll do, I'll just go through that case study, and then we can get comments on Slack channel after the course as well, and be involved in that. Right, so a little bit about me. In case anyone, I'm sure a lot of people have seen my name written down, but don't know how to pronounce it. So, Reader. It's Reader. And the surname, despite the consonants that are too close together, is Hamid. So that's Reader Hamid, and I'm Head of Solutions. And that picture was me 6 years ago on my wedding day, just to show what kids do to you after 6 years. I like this one. There's a bit of highlights about me as well. I did win the County Rugby Championship. I did score a try. 50 yards I ran to score that try. That's me. You also noticed most of these happened in the early 90s. I haven't done much since then, apart from those 10 press-ups a month ago. There you go, end of that. What is architecture? Let's go on with what is architecture. Views. People here. We've all dealt with architects and architecture. Anyone want to venture a comment? Coffee breaks, yeah, there's a lot of coffee breaks involved in doing architecture. Anyone else?
Blue sky thinking.
Blue sky thinking, okay, nice. Anybody? Anyone? Stuart? Yeah, I guess you might have an opinion.
I don't know anything, I'm here to learn.
No, that's a good point. What about the other delivery sets? Have we got anything coming through there? Visio, okay, another great one. Wow. So the value of architects is quite low by the sounds of things. Anything else? Anyone want to? Anyone from the back? No? No? All right, we'll learn then. Let's go for it. I did decide to do some crowdsourcing of definitions because it isn't actually an easy thing to define. I don't think it's an easy thing to define anyway. So I thought I'd put it out on Facebook and WhatsApp and Twitter and ask for some opinions. How to know these two guys. These are a couple of friends of mine from British Airways. So they came up with Texo, who's a project manager. They're both project managers. Don't know much. So they said boxes with lines between them. At least he said in some sensible manner. It's not my best friend. And the other guy, Andy Bateson, a clear map of the physical nature of the systems with which you are working. That's actually not a bad one, but it doesn't have everything that you need in there. So, as a good architect should do. I decided to do some research, see what I could find, and I found a couple of other quotes, which I think both together will give us a decent definition. So this one is, so I've given the reference here, planning a computer system, project stretch. Truth is, I got this from Wikipedia, which is where everyone gets it from, but I thought I'd put in that reference anyway to look a little bit clever. Now, I'll just read this out verbatim initially, and then we'll go through it. Computer architecture, like other architecture, is the art of determining the needs of a user structure and then designing to meet those needs as effectively as possible within economic and technological constraints. So let's go through the specifics. The first thing is art. Now, I didn't know where the comma should be here, so I wasn't sure what it was saying was the art, whether it was the user needs or if it was architecture itself. But architecture is an art. It's certainly not science. Science is something where you follow steps and give a definitive answer. You don't do that with architecture. You can take the same steps that one architect uses in one place, pick them up, move them to another place, and you will not have the same answer. You will not have the same result. It is more like an art. I did pharmacology as my degree, so I know what science is. And that's true, I did. And my last
So you did pest controls.
well, I'll tell you what, I did kind of, my end of year project, my last year project thesis was the effect of certain drugs on the vas deferens of a rat. Right? So that involved me killing rats. So I had to do it. No, I did. You pick the rat up.
You were the rat in that song.
No. You pick up the rat. This is how you kill them. You pick up the rat, you stroke them, keep them calm, grab their tail, whack it on the end of the table, break their neck. That's how you kill rats. But that was a methodology. That was part of the methodology. That was brilliant. I loved it. It was great. I actually, I hope this isn't a reflection on me generally, but I couldn't kill more than one rat, and so I made up the results. I got 50%, so I was happy with that. I made up the results. But the point here I was trying to make, apart from a nice story, the point I was trying to make is that I would write down the methodology, the steps you take. Someone else would copy it, those exact steps. They should get, within statistical significance, the same result. You don't do that with architecture, so it is more than that. The next thing, is someone saying something?
No. It's just an image of somebody hitting a rat with a hammer.
Okay, brilliant. The next one,
getting stuff out of your course so far.
So far, that's how you test the vas deferens of the rat. So the next thing is determining the needs of. I really like this thing. One of the things we do really well at HMRC, and it's not necessarily something we do well elsewhere, that I've seen done well elsewhere, is taking into account user needs. Your architecture isn't valid unless you have done real proper user research and it fulfills the needs of those users. Whoever those users are, I don't know who they are, fulfills the needs of those users. So must be taken into account. Really like this point. Your architecture also, within economic and technological constraints, you can add other constraints in there as well. But again, if your architecture doesn't take into account them, and we'll talk about this a bit more later on in the principles, doesn't take into account the constraints, whatever they happen to be, economic, technological, people, money, so on, you haven't really got an architecture there. And the last thing here is 1962. So this is all stuff that was recognised, what's that, 54 years ago? 54 years ago. Now, architecture, software architecture in particular, wasn't a field of computer science until about 96. They started to see that structure was needed in the stuff that was being developed, and that's the quote that was coming out with back then. It's still valid, and that's why I love this one, and that's why I took it, even though it was Wikipedia. Okay, this one here is from a guy called Dave Slawson. I did get this from Facebook, but Dave Slawson I worked with back in 2000. He's an IBMer, he's retired now, and he was an architect who worked at British Airways with me. I was a new graduate at the time, and was probably what I would call a precursor of the modern day architect. Architects before that would kind of sit in isolation, sat there, didn't really do much coding, would sit there, write big, massive 100-page documents, give it to developers, and that was it. So Dave was one of the first ones that I came across, and I still very much trust his opinion. So this is what he said: software architecture defines a component of the system. A component, get into a little bit more, but a component is a unit of functionality at a high level. Okay, so that's what a component is. Units of functionality. Doesn't really tell you much, but that is intentional. Gives you a little bit more flexibility there. And what you do is define what they do. So this is where I told you about Andy Bateson's quote earlier on, where he talked about the physical nature of a system. What was missing there was the logical nature of a system. So you define your components, meaning what do they do? It's a customer component. It's an account component. It's an order component, so on and so forth. It gives you the functionality that that component is trying to do. The actual physical bit is what they are. And that's important as well. If you don't define that, you haven't got yourself a definition of what those components are. Is it Java? Is it Scala? Is it Oracle database, which is also a component? Is it Mongo? Is it queuing system? So on and so forth. You have to define that as well, and that's the physical aspect of it. And then finally, it's how they interact. This is not just a case of let's put a whole load of components together. You have to define their contracts, how they communicate, what sort of methodologies they use, what sort of technologies they use to communicate. Is it SOAP? Is it REST? Is it JMS queues, and so on and so forth. So that's your, so take this quote and the other quote, and you've got yourself a definition of an architecture in my mind. That's what your architecture is. There was another quote from, I haven't put it on here because I didn't really know how to explain it too well, but there was another quote by Martin Fowler, and a number of people use it. Architecture is the important stuff, whatever that is. I reckon, you know, user researchers consider their stuff important, and developers do, and stuff like that, and UX people. So it's not a great one, but the point of it was things that are difficult to change, things that are hard to define, try and define it up front. All right. So often question, difference between architecture and design. What's architecture, what's design, where does the where does one stop and the other begin? It's a lot more blurred than this, but essentially your architecture, as I said, are your components. Very high level, your customer microservice, for example, may talk to a self-assessment microservice, and it may also talk to a customer database. That's kind of what your architecture would be, while your design are the software modules that sit inside it. So you've got your customer microservice, you've defined it, you defined a contract there, you defined how it should be communicating and what it should be communicating with. The design is the internal workings of that. That's essentially it. An architect role would be, obviously, the architecture. How much they're involved in the design depends on the quality of the developers on your team. An architect with strong developers probably wouldn't get involved in the design very much. That's not their realm. I worked on portal rehoming, and the developers on there were awful, so I got more involved in that than I had to. Isn't that right, Tom?
That's right, and we're still cleaning up.
All right. I didn't do any design. But it does depend. Some architects, there isn't a hard and fast rule. An architect should not get involved in design, but generally, that's the realm of developers. In the old days, you would write detailed sequence diagrams to define the design of your software. These days, your design is essentially your code. Let the right people do that and get on with it, and you get more of an agile way of doing things. Yes?
So the way the microservices communicate with each other, the fact that the databases are going to be relational or not,
Yep.
the fact that the user can see the server side or not, this is architecture, this design, or is it?
So the physical aspect of it.
So
the decision. So the question is that whether you use, for example, whether you use an Oracle database or a Mongo database, for example, does that come under architecture? Does that come under design? That comes under architecture. The actual physical nature of each of those components would come under the architecture. So even though here we use Scala as our microservices, it would be a question, a valid question is, would the custom microservices be Java? Would the self-assessment one be Python? Whatever. Would the customer database be Oracle, Mongo, XML files, whatever? That would come under the realm of the architecture. That's a good point, actually. If you've got any questions as we go along, that's fine. And the same with the Slack channel, just throw your questions out there and we'll try and answer it as we go along. All right, some architectural styles. Architectural styles or patterns, you'll see them, the terms used interchangeably, fairly synonymous. I prefer the term styles rather than patterns because patterns can feel like some more low-level aspects of architecture rather than an overall, and I'll explain that now. I took this from Mark Richards. He does a lot of talks and a lot of writes a lot of books with Neil Ford. I definitely advise you guys to go on and do some searches on them. It's really good stuff. But in a talk called Software Architecture Patterns, he says architecture patterns, I've added styles there because that's the term I use. Architecture patterns help define the basic characteristics and behavior of the application. Put that there for a reason. Quite often I'm going to have discussions, I do have discussions with people, and those who've been in meetings with me know one of the things I get frustrated most is when people say you're trying to do a purist approach. It winds me up, so don't do it. But what people are saying is that you're not being pragmatic, you're not being practical. By having an actual architectural style and sticking to, in general, the characteristics of that architectural style, you now understand what that architecture is doing, its limitations and its strengths, without having to get into the details of the module. So when we talk about doing REST and saying we want to do REST as close to pure REST as possible, it's not so that we put that on our CV, draw some diagrams and get praise from the outside world. It's because it's a style, it's a pattern that has been proven, it's been developed by, quite often people more experienced than ourselves use it. It's not because of this purist approach. So that's why I put this one up there. It does define the basic characteristics of that. Any limitations of an architectural style, you know up front, and you can then use it. You veer away from that architectural style and you're kind of getting yourselves into a little bit of the unknown. That's fine. There are times when that has to be done. So it's not a case of do that or else you're a dickhead. Do it because you have to. Do it and it's worth doing. Okay? Hey?
Instead of that, stop that recorded.
Oh yeah. Anyway, let's go on. So I'm just going to go through, not going to go into a great deal of detail with some of these architectural styles, either because they're not really worth going into detail on, or we'll have other talks where we'll go into them in a lot more detail. So first one is the classic layered, tiered, end-tier architecture, usually in the 3-tier. Simplest form, if you're doing your own personal project, you probably start off doing this without drawing anything up. You probably go for a 3-layered architecture like this. Classically, front-end layer talks to a business layer, talks to a data layer. And then you may have a couple of layers either side or wherever that span the whole lot. Usually, well, a couple of important characteristics of this that you often find with this and you ought to find is that communication is from the top to the bottom, in this case from front all the way down to the end. You won't find it the other way around, okay? And it shouldn't be the other way around. One thing you also will find is that the front end will only talk to the business layer, which will only talk to the data layer. That's the way it classically works. By doing that, the reason for doing that, it allows you to abstract away from bottom layer. You change anything in the data layer, you only have to change things here. You don't have to worry about changing in both layers. That's the reason for it, largely. It lends itself better to monoliths, but that doesn't mean, and we'll see it in a minute actually, that that same sort of idea gets applied to other architectures as well. There is a problem with this, or there is a potential pitfall that we have to be aware of. So this is a three-layered one, three-tiered, fairly standard. You could get yourself something like this. Some places will go for an extra layer, and now you call it process layer, call it an orchestration layer, whatever you want to call it, where the front end will only talk to that process layer, which talks to the business layer, which talks to data layer. Do we have anyone want to venture a guess at a problem with that, a potential pitfall? Anyone think of? I'm glad the architects are speaking up. That's both well.
So we have a comment, by the way. So Rick says, top to bottom flow also implies the communication pattern is a directed acyclic graph, which is therefore deadlock free. Over to you, reader.
Thanks, Richard. I don't know what that even means. So. But I agree with him. Yeah, can you reply back and say I agree with him? It's deadlock free, so that's the main thing. So next, pitfalls for something like this.
Small business layer along of the domains probably spread around the process layer. You end up with an any kind of domain layer that's very small, and the business now is split.
So a lot of the work is being done in the process layer, while this is nothing more than a reflection of the domain. Yeah, yeah, no, that's one pitfall that we need to be wary of. Anything else? I'll mention it then. So a lot of these layers, the way I described just now is that the front end only talks to the process, only talks to the business layer, which only talks to the data layer. What you can end up finding here is an anti-pattern, if you like, called like a sinkhole pattern or proxy pattern. Because you end up forcing, because this layer is closed and only this one can talk to it, I don't think they can see what I'm doing, so only the front end layer can talk to the process layer. For simple events, you may find that you're creating a process component that does nothing but calls to the business component. And what that does is you're coupling yourselves, you're tying yourselves in, you're increasing the amount of work that's involved, the amount of testing that's involved, and so on. One way of dealing with that is just to go, the front end, the process layer is actually an open layer. Ideally, you'd go through the process layer, but in certain circumstances, it's okay for the front end layer to do that. Then you're losing a little bit of the abstraction, but it's fine, it works. If it's needed, it's needed. So that's just the layered approach, which you will find in many. The other one, you've got service-based architectures. We're obviously in microservices architecture. Other places are SOA. Now, I do a lot of interviews with architects, and one of the questions always asked is, what's microservices? Describe microservices. More often than not, I get more often than not, you get the answer of they're small services. Okay, you know, why wouldn't you? It says micro in the name. It makes sense. That's not entirely right. So this is the key difference between the two. The actual granularity of those services are irrelevant. A microservice ideally would be have a single reason to change, but so would a SOA service. They're not actually much difference between the two in that regard. The key difference is that, keep that in mind, you've got an ESB, that's one of the important bits here. I'll go on to the next page because that shows some of the comparison between the two. Microservices do choreography and orchestration. What does that mean? I actually read quite a good one. Orchestration, compare it with an orchestra, and you have the conductor. You have the conductor who does the orchestration. So I was going to call him an orchestrator. That would have been wrong. The conductor will tell the people, you go next, then you. They know where everything has to go in the order. Choreography is in dance. Which I'm an expert at. A choreographer, guys down the line can't see me. They can't see me, so it's worthless. So I'm not going to do it. Otherwise, I would. A choreographer.
You can turn the web camera.
No, it's fine. So a choreographer each dancer knows what they should be doing next. So you create a choreography, but each dancer themselves know what the next steps are. They're not waiting to be told to do this. and that's the difference. So in SOA, you have that ESB layer that I mentioned, which does the orchestration. You call the ESB, it goes, well, I need to now go here, 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 and here. I know what the formats is of here and here, so that this one would be a REST, this one would be a SOAP, this is just a EJB, and so on and so forth. That's what the ESB would do. With microservices, each microservice knows where it should be going next. It decides which microservices to call. It knows how to call those other microservices or databases or whatever. It runs it there. So that's one of the main differences. I'm not going to go through all of these. I'll mention a couple of the key ones. The database is a key one. In SOA, you tend to have your one database that fits across, and everything at the data layer or those data services will call the same database, potentially the same tables even, and does what it needs to.
There's a question. So, doesn't the conductor in SOA help with discovery?
Yeah, absolutely. It's not a negative that you have orchestration necessarily. There are negative points to it, which means if you want to make a change to any business logic, you have to have another component you have to change, which is the ESB, which is controlled by someone else. But yes, it does help with discovery totally, and it helps to abstract or hide what those underlying services are. So that's the advantage of it, without doubt. Okay, and a couple of other things. Usually REST with our microservices, usually or REST-like, and with SOA, usually SOAP. So most SOA places tend to use SOAP. Doesn't have to. There's nothing within the SOA definition that says you have to do that.
Another question: isn't service discovery a non-requirement in a closed system?
Isn't service recovery a discovery a non-requirement in a closed system? This is Rick again, isn't it?
It is, yeah.
It depends on the requirement of the system. I don't know. I don't know the answer to that really. Anybody want to answer that? No? Sorry, Rick. Come up with one I can answer next time.
At least give them a 50-50 chance.
Yeah, give me multiple choice and we'll go with that next time. Usually, number 6, usually a microservices can be polyglot. In our case, we're not very polyglot. Polyglot means multi-technology. Your microservice could be any technology you want it to be. Your database could be any technology you want it to be. We're not very here at the moment, but there's nothing stopping us from doing that. With SOA, you tend to be limited by the SOA infrastructure that you've decided to bring on board, whether it be Oracle, SOA, or what do we have for British Airways? We had, what was the SOA? I forgot. It's probably worth forgetting anyway. So you're usually Sonic. That's it. Your Sonic ESB and Sonic SOA stack. So it's generally better. It is generally technology limited based on that. Okay. We are going to have a talk, hopefully, on microservices. We won't do SOA because we don't do that here. We'll have a talk on microservices at some point, which gets into a lot more detail. I haven't got a volunteer for that yet, but if anyone wishes to volunteer to talk about it, please do. And then REST architectural style. So one thing that you'll notice, hopefully you've noticed, is that architectural styles are not either or. You don't either do your layered or your microservices, or in this case REST. You amalgamate and use what's appropriate. So REST is an architectural style. It is used in microservices or any other one, so it's not you do one or the other. REST, again, we're going to have a talk on this. I'm not going to go into too much detail. REST was defined or described by Roy Fielding in 2000. I did try reading this about a week ago. It's horrible to read. It's an academic paper, but this is probably the key point of what REST is. So we work with resources. We manipulate those resources through representations. Self-descriptive messages are your content negotiation, which tells you so that the end client knows what those messages should mean. And this last one is, it doesn't name the acronym in here, but I think it's been taken since Hypermedia as the engine of application state, which is the horrible acronym HATIOS. So for him, that is REST. What that all means is that it tends to use, REST uses the web framework, the web infrastructure and architecture. When you use your browser and you look at web pages, that's essentially what he was doing, was describing that. That's REST. But in our case, in most cases, you're passing along data, not front-end content. Hypermedia is application state. We're going to talk about that in more detail. I think it's on the 28th of July with Malcolm and Alex. So definitely come along with that. We're doing a lot more REST here than we have in the past, so definitely come along with that. HATIOS, or Hypermedia's engine of application state, is the links that you find in some of the message formats that you'll look at. Go and look it up after this if you haven't seen it before. It describes what you can do next. So you've called my API. What is the next steps? What are the things you can do next? And it just gives you a link, and it goes on. Now, it is controversial. I don't think it ought to be, but it is controversial, and we're trying to bring that more in here. So come along to the 28th, and also it's well worth reading up on it before we go. And there's some other architectural styles, which we probably won't go into any more detail. Look them up. We do a little bit of event-driven architecture here. We may do a talk. We haven't got one set up. It may be worth doing. If there's enough interest in having one, then just give us a shout. Let me know, or put it on the community courses Slack channel. We might. So if we want to, we can do that. The other two we don't do at all. Microkernel is similar to like your Eclipse, for example. That's kind of microkernel, where you have a core system and then plugins that are added in to increase the functionality without changing the core system. So they're interesting ones as well. We won't be doing talks on that just because they're not stuff we do here. Any questions? Anything else? Anything from Rick?
No, not yet.
No? Damn it. Right. This hopefully, what are we doing for time? Oh, we've got a bit of time here. This is probably going to be the bulk. The reason why it's going to be the bulk of what we're talking about is, again, one of the most frustrating phrases you likely hear is that this is the architecturally right way of doing things, or this is architecturally better than something else. It's, you know what, I'm probably guilty of saying that sometimes as well, but it's actually a fairly empty statement. Architecturally right, better depends on certain things. There is bad, but there's not necessarily better. It sort of comes down to opinion. And it's the principles that are followed, the principles that you follow to get to the answer that are most important. If you don't follow these, or if these aren't taken into account, then you've probably flawed somewhere along the line. So we'll go through this here. 12 principles of architecture. We'll go through each of them separately. I made number 12 up, because I wrote it up. There may be added some more later on as I think about, but we'll stick with this for now. So we achieve business goals. If your architecture doesn't achieve business goals, then your architecture hasn't delivered anything. It doesn't matter whether you've done pure REST or pure SOA or pure microservices, you haven't actually done an architecture that's worth doing. So one of the roles of an architect, one of the jobs of an architect, is to understand the business goals. That's not to say no one else should, but as a developer, the business goals aren't necessarily relevant. You develop a piece of software to deliver to business requirements. That's relevant. It helps to know the business goals, but it's not relevant to be able to do. An architect needs to know those business goals. What are those business goals are? I think we've got three main ones here at HMRC. Make it easy for a customer, I think is one of them, and reduce cost and increase revenue, kind of your standard things. I think that's the three, the triangle someone's described it to me before. You've got to understand that because everything you do leads towards that. It's very high level, but that's very important to understand. If you understand your business goals, one of the other roles of the architect is to refine and question business requirements. Yeah, it's one of the roles of the architect. If you don't know what you're trying to aim for, then you can't necessarily go up and say, well, that business requirement isn't going to achieve that goal. And you can't get yourself to deliver talk about just enough of an architecture to fulfill the needs. You know, a requirement may give you too much, so that's important. Remember, I don't know if you remember the definition I put up front about from 1962, which talks about constraints. Constraints are king. When you I'm guessing it's still being recorded. Probably. Yes, there we go. We're done. These are some of the constraints that you're going to have. They all have to be taken into account. If you don't take these into account, again, you haven't actually achieved the architecture that you need to achieve. So there's technical people. Quite often we'll hear, and have heard, people say, well, I'm just going to define the best architecture. I shouldn't worry about how much money there is to spend. I shouldn't worry about what people are there. We'll sort that out. But I've got to do the best architecture. Not taking no. Your architecture has to be based on that. If your developers don't know Ruby, don't define an architecture that uses Ruby. It's pointless. If you're not on the cloud and you're on tin hardware, then your architecture is going to be different to if you're on the cloud. You've got to understand the constraints that you have. There are limits to money. You know, no one's going to spend 50 million. Well, they may not spend 50 million on your project. So don't give yourself an architecture that requires you to have 200 people working on it to deliver it within 6 months, which will need £50 million. Don't do that. You have to understand the constraints to deliver the right architecture. That's why when I say it's not a question usually of good and bad, you'll look at architecture, and architects are the worst for this. They piss me off non-stop for that. Architects will look at an architecture that happened 5, 10 years ago and say, what the hell were they thinking? That was just the most stupid thing they've done. We've got to understand the constraints that were there at the time. You got to understand that there were constraints. You don't necessarily know them. When I first started, well, I said comments.
Why do we use Scala then?
Don't get me started. Who was that?
John.
Yeah, we use Scala because it's totally unreadable and it's allows us to sound all clever.
And it's the best language in the world.
It's the best language.
Go in the Scala.
When I started, yeah. If you do find Scala unreadable, there is going to be a Scala Part 3 done by Tom on my left at the moment. Later on in August, I think it is. And there's Scala Part 1 and Part 2 on Confluence. If you haven't been to them, have a look at it. And you'll still think it's unreadable, but it's nice to hear Tom speak. When I first started coding in 2000, professionally that is, in 2000 I was only 12 at the time. I started on a project. Called Fair Explorer. It was on BA.com. And I took on some code that was already developed, an architecture developed or started to be developed. And the architecture at the time was servlets that would pull in HTML template files, dynamically create the HTML template files from the servlets and serve it up there, with JavaScript also being dynamically created based on requests and details that would be served up, and which would allow you to change options. I don't know if anyone's seen calendar-led selling on BA.com. Does anyone use BA.com? No? Yeah? There's calendar-led selling on there anyway. That was a precursor. That was a descendant of what I was working on, which was calendar-led, which was a whole month. You'd click on one day and it would change what you could do on the return. It was using JavaScript and we used servlets. Now, I have for the last, I don't know, 15, 16 years, have talked about that in the most demeaning of fashions. It was a bad architecture. Okay? Why? What, I mean, I used to say, why does this guy? Has this guy never heard of MVC? You got your view and your controller inside your servlets. It's a complete mess. But there were constraints, and it's worth understanding that, which I didn't for a long time. Back in 2000, web application frameworks, what existed, what was mature at the time. You know, there weren't many. You had the beginnings of struts, and that's actually the only one I know that existed at the time. But even that was awful. It wasn't very good. Some people would argue it's still not very good. You know, other web frameworks, web application frameworks came later, like JSF and Spring MVC and others, improved it, but they didn't exist at the time. JavaScript didn't have any clever frameworks that you have these days, your Backbone JS or your Angular or so on. So doing it the way he did it was probably to create a dynamic experience, the most sensible thing that he could think of at the time. You know, there was no Ajax. Ajax didn't come until maybe 2 years later, possibly. I don't know exactly, but it didn't exist at the time. So the constraints at the time were technical as much as anything. Now, he could have said, look, guys, don't bother trying this. We haven't got the technology. We haven't got the people. We can't do it. Don't bother. But if he hadn't bothered, BA.com would not have had a calendar-led selling application. It wouldn't have been, at the time, the most innovative way of selling flights on the internet, and it wouldn't have pushed BA.com to its business goal, which was to reach 50% of 50% of bookings online by, I think, 2005. They well exceeded that. Now, I can criticise what was done, and I would not advise anyone to do the same now, but that was as good as what could be done, and it achieved the goal. So very important to understand the constraints. Talked a lot about that, but it is important, largely because I'd like IT professionals, we're all intelligent people, we like to criticise other people. This is a reason why not to. Yeah? Be nice, I think is what I'm trying. I'll change that to be nice, maybe. Change that to be nice. Just enough is always plenty. Never do more than what has been asked for. You know, an architecture should not try to deliver some utopia. I've had this in the past before. If 2-second response time is okay, don't try and overdo it. Don't try and put caches and you know, search engines and so on to try and speed things up if 2 seconds is fine. Because as soon as you start trying to overcomplicate things, you start adding new systems in to try and solve a problem that doesn't exist. And I'll talk about the complexity in a minute, but you make it difficult moving forward, and you're not going to achieve the goals you do. So always just enough is more than enough. No, it's plenty. It's just it's not more than enough. An example I had in my last place, which was also British Airways, I went back to it, its little home. They had SOA, and one of the things they want to do was create a customer service, return customer information. And the requirement at the time was just to return, I think, let's say it was just personal details, not addresses, not anything else. It was just to return personal details. And I had a debate with one of the architects, their service architect, who wanted to add addresses, who wanted to add contact details. Why? Because well, you're going to need it at some point. We don't need it yet, but we might as well do it now because you're going to need it at some point. Except there was no requirement at that time to do it, and there was a complexity involved in it. At British Airways, in most places, a person could actually have more than one address. They could have multiple phone numbers. They could have multiple email addresses. An email address may relate to more than one person. How do you reconcile those things? You can. It's not that you can't, but if you don't have to, why would you? By doing that, you would that would have taken too long to deliver, and our business goals wouldn't have been achieved. So always just do enough. Another example was someone wanted to, House would remember this one, wanted to have a response time in 50 milliseconds. That was the end-to-end response time, 50 milliseconds. Why? Why? I don't know, because it's nice, isn't it? If you can return quicker, why wouldn't you? But to do that would have required a lot more complexity moving forward. Next thing is architecture to change. Your architecture should be taking into account that it's going to change. Obviously, I've borrowed that line, fail to prepare to fail. It's a good one. when you have delivered some software, at the time you delivered it for certain requirements, you delivered them with particular constraints, you delivered them based on the knowledge you had at the time. You have to recognise that that's going to change. Either you made a mistake, that's fine, it's not a problem, these things happen. Either the system that you are using, there were some promises that were made in terms of its performance, and you go into them and you find that the performance just isn't what you expected. You're going to have to change. Requirements change, business goals change. You have to take that into account. You have to try and think it through. One thing, a phrase I've used in the past is that we don't, so just enough is always plenty. That's kind of, don't ask what if. What if someone wants this? What if someone wants that? We don't deliver what ifs. However, architecture for change is kind of the Einstein thought experiment. But what if I did need to change it? What would that look like? What would that do? Don't spend too much time. You go, if I had to add a new system, what would that involve? If I had a change of requirement here, what would that involve? So you ask yourself the question without delivering to those what ifs. And that's where the difference between the two is. The next few help with architecting for change, the next few principles. So I talked about this a lot. Minimizing complexity, very important. I say minimize complexity, not remove complexity, not reduce complexity. As soon as you go from paper to computer, you've added complexity. So we need complexity, it can't do it. Probably if I just read that out, complexity is a measurement of the number of components you have in your system, the number of those interactions between those components, and how those interactions look like, what those interactions look like. I've put that last one, what those interactions look like, because what I don't want people to do is then go, oh, if I have 10 components, that's complex, but if I have 2 components, that's simple. But because I need to do a lot, I'll just stuff a load more into those 2 components, and hey presto, I'm done. So there is no equation, no figure. You know how we used to do metrics in the old days? Well, some people still do them with regards to code. You can't have a method that's more than 100 lines, and you can't have a line that's more than, I don't know, 80 characters or something like that. And that defines good code. We know that doesn't necessarily hold true, and I don't want the same thing to do with an architecture. More component, but it does add complexity. So why do we want to remove complexity? Complexity adds development time. So the more complexity you have, the longer it's going to take to develop. The more complexity you have, the longer it's going to take to test. You're going to have to support and maintain that. If you've got many systems, many feeds that could go wrong, then there's going to be a lot more support that's involved in that. Like I said, you can't remove complexity. As soon as you've created yourself some code, you've added complexity that needs testing. But try and minimize it where possible. Now that takes into account the constraints. If you do have a constraint that says, let's respond back in 100 milliseconds, and you're using a database that in itself can only respond back in 200 milliseconds, then you've got an issue there that you have to solve. Add another system on, or change your system, or change the way you write your code, fine. But if you can avoid it, and this goes back to just enough, if you can avoid it, avoid it. So some architectural styles are inherently more complex. Examples of that, microservices, far more complex than monoliths. Now, if you want to create something that's simple, go for your monolith. You don't have to worry about distributed. You don't have, so microservices are more complex, but they deliver to needs that we here at HMRC have, and which a lot of people have. Continuous integration, delivery, changing it. These are all advantages of it, and so the complexity is worth it, but it is more complex. Event-driven architectures are more complex than synchronous communication. But again, depending on your constraints, it's worth it. So it's worth keeping that in mind when delivering architecture. Evidence-based. You probably will hear this a lot from likes myself and the other architects, is that it's not good enough to just say, we think this is going to happen. We have a gut feeling, or we want to, I won't use real examples just in case people know what I'm talking about, but we don't want to do we want to do something because we have a feeling that this is going to happen. No, everything we have to do to allow us to reduce that complexity, to minimise complexity, has to be based on real evidence. And these are some of the things that count as evidence for our decisions. Metrics. You've put something live, like I said, you've noticed the volume is a lot higher than you expected, or the performance is a lot lower than you expected, or similar systems in the past have these characteristics. That's evidence for what you need. Use real metrics. It's great. We didn't used to have that in the old days. You didn't really have Google Analytics or nice metric dashboards, Kibana, Grafana, things like that. To be able to see it up front in a nice way, you had to used to have to trawl through logs, writing your own Perl to be able to do that, and you didn't have access to live anyway. So we're in a much better position than this old man used to be. User research, I mentioned that, very important. That counts as it. It is okay to go expert opinion. You know, if you've got a data architect and that data architect turns around and says, yeah, Oracle's plenty good enough, you know, listen to him. Or, no, you've got far too many joins there, you're going to have to find something else. Expert opinion counts as evidence, and it is fine to go, you know, yeah, Tom says Scala's great and it can do this, which it does. And Tom's a Scala expert. It's worth doing that, and that's fine. I have no problem. We have to use people. We have to use the knowledge that we have amongst us. We've got a big team here. We've got a big department. Take advantage of it. Yeah, technology characteristics are obviously very important. If you know the characteristics of a particular system, that's evidence. You'll see it. But like I said before, you can see these technology characteristics. Someone says, well, yeah, our system will work really fast, and then it comes doing it, it's not fast. Then you've got new metrics to prove it wrong. But before you've got any metrics, maybe that is the best bit of evidence you got. Well worth using it. And then the opinion of the product owner. I put that last for a reason. Not as important, but they are important still. So let's take that in. Okay. Anything? Any questions? Any questions? No. Okay. Single responsibility principle. This is a quote. I got, by the way, at the end of this, there are the references, some links to follow. So you'll see where this came from. Each software module should have one and only one reason to change. That one reason to change is also an opinion. That depends. How granular is that one reason to change? But if you can create a software module, any module, in that sort of manner, and this is what we try and do with our microservices, what we should try and do with our microservices, that it should only have one reason to change. We've got a talk on domain-driven design coming up as well. I'm doing a lot of advertising, but domain-driven design. Sell it. It's domain-driven design by Nick Tune, VOA. I know they're online, so Nick, there you go. That is all about defining your context, your bounded context, to allow you to be able to define things in a way that only has that one reason to change. If you do that, you're making it easier to just either make changes to that one component, or remove that and swap it with something else. That's where this concept of architecture for change will help as well. Just checking the time. Okay, Newcastle might be going soon. Reusable components. Anyone want to venture a guess what I mean by reusable components? Find this one an interesting one. Anybody? I'll just throw it out. Okay. Quite often you find in a lot of places some reusability is all about whether or how often something is reused. If it's not reused, then it's not reusable. And then what that means is that the goal of each component is to make it reused. And that leads to additional complexity. That leads to, and I'll talk about coupling a little bit in a minute, but it leads to putting in your contract flags that says, so that I can be reused by as many people as possible, I put a flag in my contract that says, I want this bit of information, which no one else wants, but I'm going to ask you for it. That's not what reusability is. That's not what you should be doing. If you have to put a flag in to give different data, then it may well be that they need to be different components. That's where your first question is. They're different business needs. So look at splitting those components out. Reusability is simply the ability for whatever component you write to be used by multiple different clients. And that comes from a well-defined interface, that comes from your component being defined based around functionality, usually business functionality, but also technical functionality. And if a client needs functionality that's similar but not exactly the same, then that's probably a different component, and that's fine. We don't want a proliferation of the same business functionality. So in our terms about microservices, we don't want 5 microservices doing the same thing, or very, very similar things, but at the same time, we don't want to force this minimization of microservices just on the fact that we want them to be reused, and we can claim reusability that way. If you try and force reuse, and I mean force it, you'll end up coupling, and you'll make it very, very difficult to change as you go forward. Avoid RDA. Before I get that in, any guesses what RDA stands for? I borrowed this off Mark Richards. RDA stands for Resume-Driven Architecture. Love it. How often do we see that? Let's choose a technology because it will make my CV look better. You know, I want to use.
For developers also, yeah, you agree.
Oh, everybody. I want to no transaction monitoring here. I want to use Spark. You know, let's use Spark because that's great. They're actually using it for a good reason. But we do often find that people will pick a technology because it's fashionable, because it would look good on their CV. Technology has to be used appropriately. There is absolutely nothing wrong, despite what some people may think, that you use established technologies such as Java, such as Oracle, such as what other established technologies do we have? Spring. You know, I'm not a fan of Spring, but it is an established technology. There's nothing wrong with using things that have been there for many years that have worked, if it does what you need it to do. Don't pick a technology because I've seen it in many places. Oh, let's use Mongo because it's quicker. What people actually mean is, if I can get that on my CV, I'm more likely to get another job. No. And this comes back to your evidence. If you're going to use something that's not established, if you're going to bring in a new system, give evidence as to why you're going to bring in a new system, bring in new technology. So the question on why do we use Scala, someone mentioned earlier on, we are looking to introduce Java microservices, for example. And one of the ways we're doing that is by going, Java microservice, one of the ways we're doing that is not just to introduce it and say, let's just do it. Everyone start writing Java microservices. We're going to start doing proof of concepts to prove that Java microservices do what we want them to do. It's the evidence we need. So use technology appropriately. I don't know how many people were part of a kind of a Slack debate a while back on using domain libraries or not using domain libraries. Anyone was involved in that? Did you see that?
Yes.
Yeah? Yeah? You were in there. It was quite an interesting one. Look through the archives, do a search on Slack. It was good fun. The reason why we avoid domain libraries is to reduce coupling between, and reducing coupling allows you to change more quickly. It allows the component that's being called to change without affecting its client, and it allows the client to use different components as is appropriate. It's not, we don't just do loose coupling for the sake of it, again, to be pure. It allows us to change, to move, to integrate, to deliver, to go live far more quickly. And the example of the domain library is that I think this counts as the external data structure coupling, is you get in a situation where 2 components using that same library, they are now linked. They're coupled, even though they don't call, they may never call each other. They may never call each other. Because they're linked, they have to use that same domain library. If that domain library changes, both have to change. If one needs that domain library to change for its own use, then the other one needs to change it as well. Increases testing. You have to test both microservices now. In our case, it increases and increases the chances of bugs being introduced at a later date. Where it's okay to have the main libraries would be in something like a monolith and your layered architecture. That's probably a sensible place to do it. But if one of your goals is continuous integration and delivery, and you've introduced microservices, one of the characteristics of microservices is not to use the main libraries. Don't walk away. Don't put yourself in a position where you have to do that.
So Rick has a comment. He says, balancing dry, don't repeat yourself, low duplication, with wry, repeat yourself enough, lose coupling.
Okay. Is that on the Slack channel? Yeah. So everyone have a look at that later on. I'm not going to delete that Slack channel for a while. So any comments on there, you'll be able to look it up later. I haven't got much time, so I'm going to race through these next. One's two other ways. Abstraction. What is abstraction? You probably know it. It's worth repeating it. It's about hiding the implementation from the client. You know, a good architecture should be able to say one component doesn't actually care how the other component works. Yeah. The one component doesn't care what systems you use in the background. You know, if I've got and I used to work on CRM systems, so I use customer a lot. If I create a customer component, my client shouldn't care whether I'm talking to SAP or talking to Oracle or talking to MongoDB. It doesn't care. And the advantage of that is I want to change that system. Whatever that back-end system is, I want to change it later on. The client doesn't care. It's the same well-defined thing.
John is wondering, has Des heard of number 11?
This is recorded, John. Shut up.
They haven't.
Right. Typo. I didn't say don't overdo the coupling. I meant don't overdo the abstraction. I'll correct that later on. Don't overdo the abstraction. One of the things you do find sometimes is that you abstract so much that you don't actually get the benefit of the underlying system. If you're using a system, you're using it for a reason. If you abstract too much, then you're in danger of making it so generic that it doesn't matter whether you're using a Mongo or an Oracle or whatever, you're not getting the benefits of that, or Spring even, or Play. So abstract, hide away in the right places. That's what I was saying, there's no right or wrong. It's all about trying to understand the right level of abstraction, but don't overdo it and go on that. And don't reinvent the wheel. I said about using established technologies. Company or an organisation like HMRC, like British Airways, that I was at before, like some of the banks, they're not technology companies, they're business companies. The technology is there to fulfil business needs. They don't have to be fulfilling technical needs, technology needs. Yeah? We're not Googles, we're not Facebooks, we're not Amazons. These companies are technology companies. If there's nothing out there that does what they want it to do exactly, they write their own database. You know, they create their own graph database. They'll create their new languages. You know, Apple, they do that. We're not in that. We don't have to do that. We shouldn't do that. We're not in that. So if we want to, you know, Google went ahead and created Kubernetes. Well, yeah, don't reinvent that. They've done it. You know, they've worked on it. They've scaled it. They've worked out why it works or not. That's not a comment on us here, by the way. That's just, it's there. Use it. Don't try and create your own database. I think I heard an example of someone who worked at a place where a person did decide to create their own database, and apparently it was good. It worked well. It was fast. It was powerful. It did everything it needed to do, but then he left, and no one knew how it worked, you know, because it was proprietary. Use established technologies in the right place. Even if they don't do exactly what you want them to do, they'll do most of what you want it to do, hence the 80-20 rule. If they do 80% of what you need it to do, it's fine. Probably the other 20% are nice to haves anyway. You know? Here we use WSO2. We could have created our own gateway. You know, it's not, you know, it's not rocket science, obviously. But why not use something that's out there already? Just don't reinvent the wheel. So those are my 12 principles of architecture. I will be renaming them as Reader's 12 Principles of Architecture. so you can quote me on that. I'm not going to go. We're not going to do this fully, but I just want to mention it here, and you can then go into Slack later on and come up with your own architecture case study. I was going to do it as a group, but we haven't really got a lot of time now. So the case study here, we're going to go through some business goals, requirements, and then I'd like, if you've got time and the inclination, to come up with either questions to help you fulfill an architecture or draw up a quick architecture on that. So business goals: increase customer satisfaction through greater understanding, and to increase revenue. The requirements: use real-time analysts to understand our customer better, and then make a decision and informed suggestion based on that. An engine has been procured, but it's on a 1-year trial basis. Certain constraints: all our developers are Java developers. We tend to use third-party suppliers to create that. Think of a global company, a TCS, NIT, sort of company. Our response time's 2 seconds, and we want to deliver within 6 months. Those are some of the constraints there. So go ahead, and I expect some wonderful architectures to be put onto the Slack channel. Ask questions. If there's not enough information there, ask me questions. I will make them up as I go along, but ask them anyway. And don't spend too much time, because we've got a real job to do. We'll go from there. So, blah, 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 blah. Oh, I've got them the wrong way around. This is existing architecture. Don't go yet. Read the existing architecture that exists, and I'll put that on there for you. How do I put the go in the wrong place? This is what the next phase would be. And these are some upcoming talks that are coming up. These are all on Confluence. Go have a look on Confluence. I think I've put them here. Blah, blah, blah. Let's go back for a sec. They're all on Confluence. There's a calendar on there. Add the calendar. You'll be able to go choose which ones you want to go to. Then going to start up. We're going to have two. We've got one next week, which is Web Security Fundamentals by Stuart. Then we'll have a 2-week break, and then we've got, I think, about 10 or 11 talks in a row after that, once a week. Any feedback, just come back to me or the Slack channel community courses if you'd like to see anything that's not there. If you want to do a talk, honestly, I'd love that, so please do so. These are the references I was telling you about, if you want to go have a look at them. And that's the Confluence page. Okay, thanks. And any questions? Any questions before we go? No?
A request to post a case study in that channel.
Yes, I will do that. That's not a problem at all. Anything else? Nope. All right, brilliant. Thank you very much. Are you recording?